Every year, more than 4 million people visit Yellowstone National Park. They come for the geysers, the hot springs, the wildlife, Old Faithful, erupting on schedule, like clockwork, for as long as anyone can remember. Almost none of them think about what's underneath. Because Yellowstone is not just a national park. It is the surface expression of one of the largest volcanic systems on the planet, a reservoir of molten rock so massive that, if it fully erupted, it would be unlike anything in recorded human history. Scientists have a name for this kind of volcano. They call it a supervolcano. And the question everyone eventually asks is the same one we're going to answer today, with actual science instead of fear. Is it really overdue? What would actually happen if it erupted? And how closely is anyone really watching it? To understand Yellowstone, you first have to throw out everything a normal volcano has taught you to expect. A normal volcano, like Mount St. Helens, or Mount Fuji, is a cone-shaped mountain. Magma rises through a central conduit and erupts from a single point at the top. Destructive, yes, but geographically contained. A supervolcano doesn't work that way. There is no mountain. There is no single conduit. Instead, there is a caldera, a massive depression in the Earth's surface, formed not by a mountain collapsing inward after an eruption so violent that it consumed the very structure that produced it. Yellowstone's caldera is roughly 55 kilometers by 72 kilometers. That's larger than some major cities. You can drive across it, hike through it, fish in its rivers, and never realize you're standing inside the scar of the most violent eruptions in the geological record of North America. Volcanologists measure eruption size using something called the Volcanic Explosivity Index, the VEI. It's a logarithmic scale, similar to the Richter scale for earthquakes. Each step up represents roughly 10 times more material ejected than the step before. Mount St. Helens in 1980, the eruption most Americans picture when they think volcanic disaster, was a VEI 5. It killed 57 people, flattened forests for kilometers, and was visible from space. A supervolcanic eruption is classified as VEI 8, the maximum category on the scale. That's not 5 times more powerful than St. Helens. It's on the order of 1,000 times more powerful. Yellowstone has erupted at this scale 3 times in the last 2.1 million years. The most recent was approximately 631,000 years ago. Each of these eruptions ejected enough volcanic material to bury an area the size of a small country under meters of ash. That's the scale we're talking about. Now let's talk about what's actually happening down there right now. Yellowstone sits above what geologists call a hotspot, a column of abnormally hot material rising from deep within the Earth's mantle, possibly originating as deep as the boundary between the mantle and the core, nearly 2,900 kilometers down. Unlike most volcanoes, which form at the boundaries between tectonic plates, hotspots are stationary. The North American plate is slowly drifting westward, about 2.5 centimeters per year, over this fixed plume. This is why a trail of extinct calderas stretches in a line across Idaho, marking where Yellowstone's hotspot has been over the last 16 million years, as the continent moved over it like a sheet of paper dragged over a candle flame. Modern seismic imaging has revealed that beneath Yellowstone there isn't one giant pool of liquid magma waiting to erupt, which is the image most people have in their heads, and which is, frankly, wrong. There are 2 separate reservoirs. The upper one sits between 5 and 17 kilometers below the surface. It's enormous, roughly the volume of the Grand Canyon, if the Grand Canyon were filled top to bottom. But here's the critical detail. It is not a lake of molten rock. It is more like a sponge, a body of solid rock that is between 5 and 15% molten, with that melt occupying the spaces between crystals. Below that, a second, deeper and hotter reservoir extends from about 20 to 50 kilometers down. This one has a higher percentage of melt, but it's still primarily a crystalline mush, not a void of pure liquid rock. This matters enormously, because it directly affects the answer to the question everyone wants to ask. This is the number you've probably seen in 100 clickbait thumbnails. 631,000 years since the last eruption, and an average interval between eruptions of around 600 to 800. First, 3 data points do not establish a reliable cycle. 2 intervals, one of roughly 800,000 years, one of roughly 670,000 years, is not enough data to claim a predictable rhythm, in the same way that flipping a coin twice and getting 2 heads doesn't mean the coin always lands on heads. Second, and more importantly, the percentage of melt in both magma reservoirs today is significantly below the threshold that geologists associate with eruptive readiness. Studies of the upper reservoir consistently find melt fractions in the range that corresponds to a system that is, in the words of the U.S. Geological Survey, not in a state that would suggest an eruption is imminent. Overdue is a word that implies a schedule. Volcanoes don't have schedules, they have conditions. And right now, the conditions are not there. So let's set aside the probability for a moment, which, to be clear, is currently estimated by the USGS at around 1 in 730,000 in any given year, the same order of probability as a major asteroid impact, and answer the question on pure science. If a VEI-8 eruption happened at Yellowstone, what would the immediate and long-term effects actually be? Within roughly 100 kilometers of the caldera, pyroclastic flows, superheated currents of gas and volcanic material moving at speeds that can exceed 100 kilometers per hour, at temperatures over 400 degrees Celsius, would be unsurvivable. This zone covers parts of Wyoming, Montana, and Idaho. This is, statistically, the smallest affected area. Everything beyond it is about ash. Volcanic ash is not like the ash from a fireplace. It's pulverized rock and glass, sharp, abrasive, and heavy when wet. Based on modeling of past Yellowstone eruptions and prevailing wind patterns, areas within a few hundred kilometers, much of Wyoming, Montana, and the surrounding region, could receive ash deposits of a meter or more. That's enough to collapse roofs, kill crops and livestock, and render the area uninhabitable in the short term. Further out, across much of the central United States, into the Midwest, ash deposits of several centimeters would be expected. That's enough to shut down agriculture across the country's primary grain-producing regions, choke water supplies, ground all aviation across North America, and disable electrical infrastructure, as wet ash conducts electricity and causes widespread short-circuiting of transformers and power lines. The longer-term and arguably more dangerous effect is global. A VEI-8 eruption would inject enormous quantities of sulfur dioxide into the stratosphere, where it would convert into sulfate aerosols, tiny reflective particles that block incoming sunlight. Based on the climate effects observed from much smaller eruptions, the 1991 eruption of Mount Pinatubo, a VEI-6, cooled global average temperatures by about half a degree Celsius for roughly 2 years. Scientists estimate a Yellowstone-scale event could drop global temperatures by several degrees for years, possibly a decade or more. This is sometimes called a volcanic winter. A multi-year global temperature drop of that magnitude would severely disrupt growing seasons worldwide, not just in the United States. Global food production, already operating with limited surplus margins, would face its greatest test in recorded history. This is the real story of a supereruption. It's not really about lava. It's about a planet that gets noticeably colder and darker, everywhere, for years. Here is the part of the story that should make you feel better, not worse. Yellowstone is one of the most intensively monitored volcanic systems on the entire planet. The Yellowstone Volcano Observatory, a partnership between the USGS, Yellowstone National Park, and the University of Utah, operates a continuous, real-time monitoring network. More than 40 seismometers continuously record ground motion across the region. Yellowstone actually experiences between 1,000 and 3,000 earthquakes every year, the overwhelming majority too small to be felt, caused by the normal flexing and settling of a geologically active area. A genuine precursor to eruption would show a dramatic, sustained departure from this baseline, not a